Today we're going to talk about a term that is absolutely everywhere, machine learning. You see it on your phone, you hear about it in the news, but what does it actually mean? So, to really get a handle on machine learning, let's start with a problem that I think we can all relate to, the spam filter. It was actually one of the very first ML applications that millions of us started using every single day way back in the 90s. And the difference between how we used to do it and how we do it now is just night and day. Okay, so the old way, you had programmers literally sitting there looking at spam, finding a pattern, like the phrase "for you," and then writing a specific rule to block it. But you know what happens next? Spammers just change it to "for you." And pretty soon your program is this huge, messy list of rules that's just impossible to keep up with. The ML way, though, is totally different. The program learns on its own which words are good predictors of spam just by looking at thousands of examples. It actually adapts. Yeah, with that traditional approach, you are always playing catch-up. Spammers change one tiny thing, and you have to go write a whole new rule. You're just constantly one step behind. And this right here is the fundamental shift in thinking. Instead of trying to teach the computer a massive list of rules for what spam looks like, you teach it how to learn for itself what spam looks like, straight from the data. So that really brings us to the core idea. If machine learning isn't just a giant, complicated list of rules, what is it really? Let's get a little more formal about it. Okay, this is the classic definition from computer scientist Tom Mitchell. And it might sound a little academic, but it perfectly captures what's going on. It's all about getting better at something by learning from experience, just like people do. So how does this actually apply to our spam filter? Well, the task, T, that's simple. It's flagging emails as spam or not spam. The experience, E, that's all the training data. Thousands of examples of what spam and normal emails look like. And the performance measure, P, is just how good it is at its job. Usually it's accuracy, right? The percentage of emails it gets right. So with more experience, more data, its performance just keeps getting better. Now, it's really important to know that machine learning isn't just one single thing. It comes in a few different major categories or flavors, and it all depends on how much supervision it gets while it's training. So the most common type by far is supervised learning. This is what our spam filter is doing. The data you feed the algorithm comes with the right answers, or what we call labels. You show it an email and you tell it, hey, this one is spam. You show it another and say, nope, this one's fine. You are literally supervising its education. A really great way to think about this is like studying with flashcards. You see the question on the front, you take a guess, and then you flip it over to see the correct answer on the back. That feedback, that's the supervision. The second major type, unsupervised learning, is, well, you guessed it, the total opposite. Here, the training data has no labels. The system gets zero answers. Its whole job is to just look at all this data and try to find hidden patterns or structures all by itself. So, for example, it might be able to find groups of similar visitors to your website without you ever telling it what groups to look for. The analogy here? Imagine someone hands you a giant, completely mixed up box of Legos. You don't have an instruction manual, so you just start sorting them into piles on your own. All the red bricks go here, all the little square ones go over there. You're finding the structure yourself. Now, there are other categories too. Semi-supervised learning is kind of a mix of the two, where you have a ton of data, but only a tiny bit of it is labeled. And then you've got reinforcement learning, which is a whole different beast. That's where a system or an agent learns the best way to do something by trying stuff and getting rewards or penalties in return. Think about training a robot to walk. So we get the theory, but what does a machine learning project actually look like from beginning to end? Let's just quickly walk through the main steps.
First, you have to frame the problem. What are we actually trying to accomplish here? Then you get the data. And let me tell you, this is often the most time-consuming part. You have to gather it, clean it up, and get it ready for the algorithms. Step 3 is the fun part. You select a model and you train it. That's where the learning happens. And finally, and this is key, you don't just launch it and walk away. You have to monitor and maintain the system to make sure it keeps working well. And this 4-step process isn't just for spam filters. It's the same basic recipe for building systems that predict housing prices, recommend movies on Netflix, or even help a self-driving car understand the world around it.
Now, as powerful as this all sounds, it is so important to understand that machine learning is not magic. It's a tool. And like any powerful tool, it comes with its own set of very real challenges. So, you've framed your problem, you've gathered your data. What are the common traps that are waiting to trip you up? Well, quite a few things, actually. you might not have enough training data for the model to really learn anything useful, or your data might not actually represent what the model will see in the real world. That's a big problem called sampling bias. And of course, if your data is just messy and full of errors, you know the saying, garbage in, garbage out. But two of the absolute biggest challenges you'll face are overfitting the data and underfitting the data.
Overfitting is a huge one. This is when the model performs incredibly well on the data it was trained on, but it completely falls apart when it sees new data. It's basically memorized the training examples, including all the random noise and junk, instead of learning the actual underlying pattern.
And that problem, overfitting, it really comes back to this one central truth. A model is only as good as the data you feed it. The algorithms are amazing, but they are completely at the mercy of the quality of the data they learn from. So if there's one thing you take away from all this, let it be this. Machine learning is, at its heart, about making machines get better at something by learning from data, instead of having people write out every single rule by hand. This shift in how we build things gives us an unbelievably powerful new tool. And that leaves us with the real question, right? As this tool gets more and more capable, what problems are we going to choose to solve with it?